Hi students, in this video we can discuss the short and long type question answers. The first question is coming from 2 to 3 marks. Okay, the first question, why does carbon form compounds mainly by covalent bonding? We know the answer, isn't it? Because carbon has 4 electrons outermost shell. And to attain stability, it cannot lose 4 electrons. Why? Because it requires very huge amount of energy to lose 4 electrons. Or it cannot gain 4 electrons. Why? Because it is very difficult for 6 protons to hold 10 electrons. So what it can do? Therefore, it completes its octet by sharing electrons. That means forming covalent bonds, and thus they form covalent compounds. Okay. Second question, list the two properties of carbon which lead to the huge number of carbon compounds we see around us. We know the answer is 2 points only. We need to say catenation and tetravalency, and we need to explain the both with the definition. Okay. Next is, why do covalent compounds generally have low melting and boiling points? We know they are covalent compounds are formed by sharing of electrons. So while the bonds within the molecule are strong, okay, the bond within the molecule, so the bond formation is very strong, but the forces of attraction between the molecules, that means intermolecular force of attraction, are very weak. So a small amount of heat energy is sufficient to break these weak forces. So they show low melting and boiling points. Okay. Now the next question, list any two of its characteristics. So define homologous series and list any two of its characteristics. Homologous series is defined as a group of organic compounds having the same functional group and similar chemical properties where successive members differ by a CH2 unit. Okay, so that is a definition. You can give the definition another way also, no problem. And the characteristics are adjacent members differ in molecular mass by 14U, and they show a regular gradation in physical properties such as boiling point and melting point, molecular mass, etc. They are increasing regularly, regular gradation in physical properties. Okay, so these are the two characteristics of homologous series. Then one more you can say, they can be represented using a simple general formula, simple general formula. Okay, that also you can add if you want. Next question, draw the electron dot structure of ethane, ethene and ethyne. So when you get or when you're asked to draw the electron dot structure of a compound, what you have to do first is draw the bond line structure. Okay, and make sure that there are 4 bonds around the carbon. Then once you get the bond line structure very clearly, or it is correct, you can go for the electron dot structure. So for every bond there should be a pair of electron like this. Okay, so this is ethane. Ethane, we know there is a single bond between carbon, one pair of electrons are being shared. And for ethene, two pairs of electrons are being shared between carbon. Then when you finish drawing, you have to check whether all the elements are happy with octet, or the electron, sharing is complete with its octet, except hydrogen. Hydrogen need only 2 electrons. Okay, so in all these cases, see, 2, 4 plus 4, 8. This carbon, for every carbon, this carbon 2, 2, 2, 2, or 2 into 4, 8. This also 2 into 4, 8. Okay, and coming to this carbon, this is 6 plus 2, 8. 6 plus 2, 8 for this carbon. Okay, so every carbon or every element should be uh, complete its octet by sharing. Okay, so that is the thing you have to be very careful about. That can be very easily drawn by drawing the bond line structure first. Okay, for example, in the case of ethyne, I'll draw here ethyne. Okay, For example, ethane, if you want to draw ethane, what you have to draw is, first you have to draw uh, the carbon ethane. The formula is C2H2. So, two carbon should be bonded, at least one. One bond should be there. Then there is hydrogen. That also should be bonded. Isn't it like this? Now check whether the carbon is having four bonds around. No. For this carbon only two bond. This carbon also only two bond. So it has to be completed by extra bonds here. Then we got the bond line structure. Okay. Once you got this bond line structure, what you have to do is, for every bond like this, draw, make a pair of electron. For three bonds, so three pair of electrons. Only one bond, one pair of electron. Okay, that is the way you are making the electron dot structure. Okay, then it is very easy, there won't be any mistake as well. Okay, next question is, what is a functional group? Identify the functional group in CH3CH2CHO and CH3COOH. So what is a functional group? The answer is, a functional group is an atom or a group of atoms that defines the chemical properties of an organic compound. Okay, that is the definition. Then the functional group, it is CHO, aldehyde, COOH, acid, carboxylic acid. Okay. Next question, distinguish between esterification and saponification with the chemical equations. Okay, esterification definition you can give. You can give the equation. Saponification definition you can give the equation like this. Okay, so that is simple or direct question test. Then next is also, what is hydrogenation? What is its industrial application? Hydrogenation, we learned it is addition of hydrogen to unsaturated hydrocarbons in the presence of a catalyst like nickel or palladium to form saturated hydrocarbons. What is in industrial application? It is used to convert vegetable oils which are unsaturated into vegetable ghee or vanaspati which is saturated. Okay, so that is also a simple direct question. Give a chemical test to distinguish between ethanol and ethanoic acid. It's an indirect. Okay, the test answer is sodium bicarbonate test, you can say. So add NHCO3, sodium bicarbonate, to both. Only acid, ethanoic acid, reacts to produce brisk effervescence. In the other case, ethanol does not react. Okay, so that way you can distinguish between ethanol and ethanoic acid. Ethanol will not react with the NaCO3, whereas ethanoic acid gives brisk effervescence. Okay. Then, why do soaps form scum with hard water while detergents do not? We discussed the answer in the short, and while we were discussing the short answer, it will not react with the sodium and magnesium, calcium and magnesium salts present in the hard water, not detergents. Okay, whereas soap forms scum. Now coming to long answer questions, again the repeated questions. What is a homologous series? Explain with an example. Write the name and general formula of the series to which C3H8 belongs. List any two characteristics of homologous series. Discuss except this B part. Okay. So B part we can say C3H8. So it comes under general formula CnH2n plus 2. Isn't it? So it has to be an alkane. Okay, it belongs to an alkane series and with the general formula CnH2n plus 2. Okay, then the already discussed answers. Next is, explain the formation of micelles when soap is added to water. Will a micelle be formed in other solvents like ethanol? Give reasons. Why are soaps ineffective in hard water? Okay, the answer is coming first part. Formation of micelle. We discussed while we are discussing. Anyway, the answer is given in a very proper way here. Soap molecules consist of a hydrophilic head attracted towards water and a hydrophobic tail repels water. When added to water, the tails cluster around dirt or oil while the head point outwards, forming a spherical structure called micelle. So that is how micelles are being formed. Then there's will a micelle be formed in other solvents like ethanol? No, micelles will not form in ethanol. Ethanol is a non-polar solvent. Okay, so we know the soap is having an ionic end, which will dissolve only in polar solvents. Okay, so ethanol is not a no, ethanol is a non-polar solvent or not a polar solvent. So no micelle formation will be taking place. Okay, so what happens is the hydrophobic tail will dissolve in ethanol. It will not form micelle. Okay, the hydrophobic tails of the soap dissolve in ethanol rather than clustering away from it. Next, number C, why are soaps ineffective? That we already discussed. So they do not form scum with the detergent. Then an organic compound A is a constant of all alcoholic drinks. So it's very clear it's an alcohol. A on heating with concentrated sulfuric acid at 443 Kelvin gives B. We are getting the answer right. And define A and B. A, we know we learnt only one alcohol, that is ethanol, and B, this is dehydration reaction, isn't it? So it is B has to be ethene. Then write the chemical equation for the formation of B. That means dehydration reaction equation. We have to write what is the role of constant sulfuric acid. It is dehydrating agent we learnt. Then give one use of A and one physical property of B. Use of A, that means ethanol. Answer is given here itself, isn't it? It is constant of alcoholic drinks, or else we can say another also. Ethanol is used as a solvent fuel. Ethene is a colorless gas. Okay, physical property of B they are asking. Ethene is a colorless gas. Okay, then this one A is ethanol. Answer C. How they are giving? They are giving in a proper way. First part A is equal to ethanol, and the chemical formula in the bracket B ethene with chemical formula, then the dehydration reaction, and then constant sulfuric acid act as a dehydrating agent, and the use and the physical property of ethanol and ethene. Okay, so systematically you have to give the answers in a proper way with proper numbering also. Okay. Next question, what is esterification reaction? Again, repeated question. Why write a chemical equation for it? How can you distinguish between ethanol and ethanoic acid? We already discussed. Define saponification and write the reaction. Saponification we will discuss. All others we discuss. Saponification is the alkaline hydrolysis of an ester to produce soap. This is a bit different definition. We can say in a simple way you can say it is a decomposition of an ester into the corresponding acid and alcohol by the in the presence of an alkali. You can say like that also. Okay, saponification very much given in the text. Okay, it is a disintegration or breaking of an ester into the corresponding acid and alcohol in presence of an alkali. Since an alkali is present, the acid formed is converted into the corresponding salt. Okay, and you can give the equation. Saponification reaction ester plus NaOH gives sodium ethanoate plus ethanol. Okay, then explain why carbon cannot form C4 plus C or CF4 minus. First answer we discussed the same, but they are asking in a different way. Okay, draw the electron dot structures of NH3 and CO2. Why are carbon and its compounds used as fuels? Okay, so number A, carbon has, we discussed already, it cannot lose or gain 4 electrons, that's its shares we discussed. For diagram, draw the electron dot structure of ammonia. See, when you draw this diagram, be very careful that the 2 electrons which are not taking part in that covalent bond formation should be drawn here. Okay, it should be shown here, then only nitrogen will be complete with its octet. Okay, and coming to carbon dioxide, this is the electrons of carbon. See, with 8 electrons, carbon has 4 electrons. It is joining with the oxygen on either side. This is carbon dioxide. Then the next question is C part. Why are carbon and its compounds used as fuels? The thing is they have very high calorific values. Calorific value means the energy it releases during burning. Okay, so it's they have got very high calorific values and undergo combustion very easily, releasing a large amount of heat and light energy. That is the reason their calorific value is very high. And not only that, they are environment friendly. They release only carbon dioxide and water. Okay, so mm, that's all for this video. Thank you. Uh, we'll meet once again. Okay, thank you.